Imagine a digital ledger. This ledger is special. It's not stored in one place. It's spread across many computers. Everyone can see the information. This is a blockchain. Think of it like a book. Each page is a block. Each block records new information. Once a page is full, it's added to the book. This creates a chain of blocks, hence the name blockchain. This chain is secure. It's very difficult to change information once it's added. This makes blockchain a reliable way to store and track data. The idea of blockchain has been around for a while. It started in the 1990s. Researchers wanted a way to create tamper-proof timestamps for digital documents. They laid the groundwork for what we know as blockchain today. Fast forward to 2008. A mysterious person or group called Satoshi Nakamoto launched Bitcoin. Bitcoin used blockchain technology to record transactions. This was a revolutionary moment. Bitcoin showed the world the power of blockchain. It sparked a wave of innovation. People started exploring other ways to use this exciting technology. Let's peek under the hood. What makes blockchain tick? How does it manage to be so secure and reliable? A blockchain is built on three key ideas: blocks, decentralization, and consensus. These concepts work together to create a robust and trustworthy system. Blocks are like containers. They hold information about transactions. Each block contains a list of transactions, a timestamp, and a reference to the previous block. Each block is linked to the previous one. This creates a chronological chain of data. This linkage ensures that once a block is added, it cannot be altered without changing all subsequent blocks. Decentralization means the blockchain is not controlled by one entity. Instead, it operates on a peer-to-peer network where each participant has equal power. It's spread across many computers. This makes it resistant to attacks and censorship. If one computer fails or is compromised, the network continues to function seamlessly. Consensus is how the network agrees on the truth. Various consensus mechanisms, like proof of work or proof of stake, ensure that all participants agree on the state of the blockchain. When a new block is added, all computers on the network must verify it. This verification process involves complex algorithms and ensures the integrity of the data. This ensures everyone is on the same page. Synchronization across the network maintains the blockchain's accuracy and reliability, making it a powerful tool for secure and transparent transactions. Blockchain technology comes in different flavors, each with its own unique set of features and benefits. Think of it like ice cream, where each type offers a different experience. You have your classic vanilla, representing the simplicity and accessibility of public blockchains, your rich chocolate, symbolizing the robust security of private blockchains, and your refreshing strawberry, embodying the collaborative nature of consortium blockchains. Each type of blockchain has unique characteristics that cater to different needs and use cases. Public blockchains like Bitcoin and Ethereum are open to everyone, providing a decentralized and transparent platform. Anyone can join the network, view the data, and participate in transactions without needing permission. It's like a public park, open for all to enjoy, where everyone has equal access and can freely participate. Private blockchains, on the other hand, are permissioned and controlled by a single organization. Only authorized users can access and use the network, ensuring a higher level of security and privacy. It's like a private club with restricted entry, where only selected members are allowed. Consortium blockchains are governed by a group of organizations, providing a middle ground between public and private blockchains. They offer a balance between control and transparency, allowing multiple entities to collaborate while maintaining some level of decentralization. It's like a partnership where multiple entities collaborate and share resources, ensuring that no single entity has full control, promoting trust and cooperation among the participants. Different industries can benefit from different types of blockchains, depending on their specific needs and requirements. For instance, public blockchains are ideal for transparency and openness, private blockchains for security and control, and consortium blockchains for collaborative efforts. Understanding the different types of blockchains can help organizations and individuals choose the right one for their needs, ensuring they leverage the full potential of this transformative technology. Section 5, Beyond Bitcoin, Blockchain's Adventures in Various Industries. Blockchain is not just about cryptocurrencies. While Bitcoin brought blockchain into the limelight, its potential stretches far beyond digital currencies. Its applications are vast and ever-expanding. From finance to healthcare, supply chain to entertainment, blockchain is making waves across various sectors. It's like a Swiss Army knife, versatile and useful in various situations. Each industry finds unique ways to harness its power. In finance, blockchain can streamline payments and reduce fraud. Traditional banking systems are often slow and prone to errors, but blockchain offers a more efficient alternative. Imagine sending money across borders instantly and securely. No more waiting days for transactions to clear or worrying about high fees. That's the power of blockchain. It ensures that transactions are not only fast, but also secure and transparent. Supply chain management can benefit from blockchain's transparency. Every step of the process can be recorded and verified, ensuring that products are genuine and sourced ethically. By tracking products at every step, businesses can ensure authenticity and prevent counterfeiting. This is crucial in industries like pharmaceuticals and luxury goods. Healthcare can leverage blockchain to securely store and share patient records. This not only protects patient privacy, but also ensures that records are accurate and up to date. This can improve data privacy and interoperability between healthcare providers. Imagine a world where your medical history is accessible to any doctor you visit without compromising your privacy. These are just a few examples. From voting systems to digital identities, the possibilities are endless. Blockchain's potential is limited only by our imagination. As technology evolves, so too will the innovative ways we apply blockchain to solve real-world problems. Section 6. Bridging the digital divide. The quest for blockchain interoperability. As more blockchains emerge, it's important to connect them. This is where interoperability comes in. It's like building bridges between different islands, allowing them to communicate and share resources. Blockchain interoperability enables different blockchains to work together seamlessly. This can foster collaboration and unlock new possibilities. Imagine a future where you can easily transfer assets and data between different blockchains. This would create a more interconnected and efficient digital world. Section 7. The energy dilemma, blockchain's environmental footprint. Blockchain technology, while transformative, is not without its challenges. One concern is its environmental impact. Some blockchains, like Bitcoin, consume a lot of energy. This energy consumption is mainly due to the mining process. Miners use powerful computers to solve complex mathematical problems. This requires a significant amount of electricity. However, there are ongoing efforts to make blockchain more sustainable. Researchers are exploring alternative consensus mechanisms that are more energy efficient. Section 8. Blockchain in the labs, a playground for researchers. Blockchain technology is a hotbed of research and development. Scientists and engineers are constantly pushing the boundaries of what's possible. They are exploring ways to make blockchain faster, more scalable, and more secure. They are also investigating new applications for this transformative technology. Universities and research institutions play a crucial role in advancing blockchain technology. Their work will shape the future of this exciting field. Section 9. Real-world encounters blockchain's practical applications. Blockchain is no longer a futuristic concept. It's already making its mark on the real world. From supply chains to voting systems, blockchain is being used to solve real-world problems. For example, some companies are using blockchain to track the origin of food products. This helps ensure food safety and prevents fraud. In some countries, blockchain is being tested for use in voting systems. This could make elections more secure and transparent. These are just a few examples of how blockchain is being used to make a positive impact. Section 10. The future is decentralized. Blockchain's transformative potential. The future of blockchain is bright. As the technology matures, we can expect to see even more innovative applications emerge. Blockchain has the potential to revolutionize various industries, from finance and healthcare to government and education. It can empower individuals, promote transparency, and create a more equitable and efficient society. The possibilities are truly endless. Section 11. Conclusion. Embracing the blockchain revolution. Blockchain technology is a game changer. It's a powerful tool that can transform the way we live, work, and interact with the world. While challenges remain, the future of blockchain is full of promise. By embracing this transformative technology, we can unlock a future that is more secure, transparent, and equitable for all.